All right, we're live here with Jay Boobs, and we're looking at number 4b, and it says that we have zeros occurring at 3i, and negative 3i. By the way, if you know that 3i is a root, it's called a complex root, then negative 3i has to be 1 also. If they tell you 5i is a root, negative 5i has to be 1 also. The imaginary roots all come in pairs, and its partner is its conjugate. So if I tell you negative 7i is a root, so is 7i. All right? They always come in what are called conjugate pairs. So if you know that these are the zeros, then you can write this out like this. How many roots are there? 3. 1, 2, 3. Let's just replace R1, R2, and R3 with those numbers that I circled in red. So if the first one is 3, then the first parentheses is x minus 3. If the second one is 3i, then the second parentheses is x minus 3i. And if the third one is negative 3i, it's x minus 3i or plus 3i. Now, before we go any further, I don't like my equations to have i's in them. Right? Yes. You can't just poke their eyes out. What you have to do is you have to kind of expand it somehow. So the part that I'm putting in green parentheses or green brackets here, I want you to FOIL that part. The part that I left in red, let's leave it alone. Now the green part will become x times x squared. And then that's from this. Okay. Then you'll have the outside and the inside, but I already told you they were conjugates of each other. So what happens when you add the two conjugates? They cancel, so you don't have an oi in your FOIL. The oi cancels. You just have full. You just have first and last. Well, the last part is negative 9i squared. I'm going to make this disappear. Negative 9i squared. I squared is negative 1, which changes the sign of the negative 9 to plus 9. So that second parentheses is x squared plus 9. So that's the basic setup for this polynomial. It has one real root at 3 and two imaginary roots. Where'd the I go? The I squared was negative 1, which changes the minus 9i squared to plus 9. Okay? Remember, this used to say minus 9i squared, but this I squared is negative 1, which turns the minus to plus. We're not done, though, because we still need to find A. Yeah, A can be found now by plugging in your y-intercept. Then you'll have 0 minus 3 times 0 squared plus 9. So we have negative 27a equals negative 54. A must be 2. Well, I plugged in 0. Right? When you plug in 0 here for both x's, you get negative 3 times 9. Okay. Yeah, don't do that. So A must be 2. So the final answer is 2 times x minus 3 times x squared plus 9.